So 4b is just the, what are we doing? AROC. F of x is the natural log of x, and I'm going from 100, 103. Let's see. So we do the y's. So the log of AROC. The log of 103 minus the log of 100 over 103. I'm going to go with, that's a calculator up top. Or if you want to leave it exact, which I'm assuming you looked at the solutions and that's why you asked about it. Is that what it is? If you want to leave it exact, how do you simplify that? Do you remember? You can't subtract them, but you can do something. Divide. Remember that condensing? You got those couple log properties, and the one with, if the base is the same, if you're subtracting. Let's see, is equal to the log base b of a over c. You can divide those. So I would say the only way you can subtract this, maybe we say that this is the log of 103 over 100 divided by 3. Which you could do without a calculator, hopefully. Dividing by 100 is just moving it 2 places to the left. Does that make sense? Yeah. Were these, okay, so, this was non-calculator. So you'd leave it like that. This would probably be like a multiple choice question where that would be on there. But if you are free response though, leaving it just like that is okay. Because FRQs, if you can plug it into a scientific calculator, then it's okay to leave it like that. You said 5? Ooh, 5's a good one. And it's a no calculator too. Cotangent x. The first one is from pi over 4 to 3 pi over 4. So AROC is going to be the cotangent of 3 pi over 4 minus the cotangent of pi over 4 divided by 3 pi over 4 minus pi over 4. Bottom's easy, right? Right. How about the top, though? Cotangent of 3 pi over 4. So where am I, first of all? Where am I on the unit circle? Quadrant 2? 3 pi over 4. So you already know this is my thought process on these. When you're an over 4 and you're a tangent value, every tangent value at an over 4 radian is what? 1 or negative 1. So you just got to figure out what quadrant you're in, right? In the case of quadrant 2, that's where my cosine is negative but sine is positive. So no matter which one I divide by what, I'm still going to be negative 1. Do you agree? Okay. So negative 1. Now pi over 4. Where am I at pi over 4? Quadrant 1, right? That's that very first one. That's a positive. So it doesn't matter if I do cosine divided by sine or sine divided by cosine, I'm positive. So it's negative 1 minus 1 over 2 pi over 4. So negative 2 over pi over 2. Multiply by the reciprocal, and you get negative 4 over pi. Then for part B, yeah. So cotangent is just the reciprocal. Instead of sine over cosine, it's cosine over sine. So, right, you're still dividing by the same number, so we're just looking at the signs there. Other questions about that part? All good? How about part B? It goes from pi over 6. So this one's a little bit harder because this one I am going to look at my actual values. So my average rate of change is going to be cotangent pi over 2 minus cotangent pi over 6 divided by pi over 2 minus pi over 6. Cotangent of pi over 2. Remember, cotangent is cosine over sine. So at pi over 2, where am I at pi over 2? Straight up, right? Coordinates at pi over 2 are 0, 1. This is cosine and this is sine, right? 0 over 1 is 0. So the cotangent at pi over 2 is 0. Notice the tangent, if you look at your circle, the tangent's undefined because it divides by 0, but the cotangent is defined and it's 0. How about pi over 6? Where am I there? First quadrant, that very first click up right there, right? So at pi over 6, my coordinates are what? Anybody? That's right. So now if I want to do cosine divided by sine, cosine and sine, so square root of 3 over 2 divided by 1/2. I'm going to do square root of 3 over 2 times 2 over 1, which is, y'all okay? I'm going to make this 3 pi over 6, common denominators and whatnot. 3 pi over 6 minus pi over 6 would leave me with 2 pi's over 6. So I have negative square root of 3 over pi over 3. Multiply by the reciprocal, so it's negative 3 root 3 over pi. Does that make sense? Well, okay. Y'all are dead this morning. So I took the top and I multiplied by the reciprocal of the bottom, so 3 over pi. And flipped it. Seven and 11. 7-11. 7-11. Accelerating from a standstill. So this is where I have all these points, and what I would do is I would just try first. You're finding the slope of the, oh, I didn't see the first part. The slopes of the secants PQ1, PQ2, PQ3, PQ4, and arranging them in order in a table. So I need to know the coordinates first, because if I'm going to find the slope of PQ1, PQ2, if I'm going to find all those slopes, then I need to know their coordinates in order to find the slopes, right? So coordinates of P look to me to be about 2650. Q1 looks to be about 10 to 25. Q2, what y'all put for Q2? 14, 375. We're just kind of estimating as best we can. Q3, maybe 16 up to maybe 475. Q4, it looks like about 17 and a half, but I'm going to go with 7. I'm just going to go with 17. 17,550 maybe. And so now what I want to do is find the slope between all these points. That's all I'm doing. So between these two is going to be PQ1. So 650 minus 225 over 20 minus 10. And this should be a calculator problem. What do you get? Oh, I see what you're saying. 42.5. PQ2. So now between these two, 375 minus, nope, I'm just kidding. I started with 650. Let me start. 650 minus 375. It really didn't matter, but 14. Gosh, Stacy. 20 minus 14. My computer's really laggy. 45.833. PQ3, 650 minus 475 over 43.75. And then PQ4 for the final one, 650 minus 550 over 20 minus 100 divided by. All right, so there we go. Remember, these are slopes, and ask you what the appropriate unit for the slope was. What do you think? Meters per second. That's exactly right. How'd you come up with that? That's exactly right. I'm doing Y's up top. That's meters. I'm doing X on the bottom. That's seconds. So it's meters per second. Estimate the velocity at point P. Did I do something wrong on mine? These aren't what they got. Were y'all watching me? 16, 475, 18. Close. $650 minus 475 divided by I think my points must be off. Oh, they used 18 for this one, which would put this at 50. And they used 16.5. Well, they should have defined that if they wanted us to do that, which would put this closer to 50. So what they're getting at is the closer you get if this is P, Q4, Q3, Q2, Q1, as you continue to do secant lines and you do the slope of those secant lines, the closer these 2 points get together, the closer that it's coming to what? The slope of which point? the tangent through P. So it looks like, because as it closes in and there's less room, the closer and closer it gets to this slope, this tan line slope right there, is what they're wanting you to see from that problem as it closes in. Does that make sense? No? So if you have a curve like this, and let's say I wanted the slope of that tan line there, okay? If I found secant line, so let's say I had this point, if I found the slope of this secant line, right? It's not, you see how different the purple is from the red. But the closer together these points get, the closer the slope approaches the slope of the tan line. And that's all they're wanting you to see. And that's essentially what we're doing in that difference quotient. As h gets smaller and smaller, remember h is the distance between these 2 points. As that closes in, it approaches the slope of the tan line. So we use secants to estimate sometimes if they're really close. Y'all okay there? That makes sense? Y'all didn't want biscuits? I don't know. I think they're sausage biscuits. Strawberry jelly in the bag. Okay, what else from your homework? 11. Oh, you said that. I'm sorry. That's a no. Since the new lady took over in the cafeteria, they seem to serve pretty good food now. Who? Who's that? Here? Wynn said that the mac and cheese here is pretty good. He had it the other day. He brought it up here. I think that was good. What do you say, Henry? No? Really? That's because it was free last year. Maybe that's why. It's not free this year, so maybe it'll get better. All right, number 11, y equals 1 over x minus 1. This whole reciprocal function, right, my rational functions. At x equals 2, I want to find the slope of the curve at x equals 2. So this is where I have to use my difference quotient. The limit as h approaches 0 of, let's just write out the equation, f of x plus h minus f of x all over what? H. But I know my 2, so that, I know my x is 2, so that makes my life a little bit easier. It's not quite as conceptual plugging in. So I need the limit as h goes to 0 of f of 2 plus h minus f of 2 over h. And if you want, come off to the side and do your f of 2 plus h and f of 2. I did it in the problem yesterday. It seemed to confuse some of you a little bit. So coming off to the side or doing it in the problem? That's the x going in, right. So it's going to go in for the x here. So it's the limit as h goes to 0 of 1 over, remember that's not x anymore, it's 2 plus h, but that minus 1 is still there. These are fun, I think. I said that yesterday. I thought it was crazy. Minus 1. Minus f of 2, so now I'm going to plug 2 in for x, so 1 over 2 minus 1. Everybody goes over h. This is the limit as h, and get in the habit, I know that's aggravating to write that every time and every step, but do it because you can lose points if you don't. So be in the habit of doing it. Writing that limit before it each time. All right, that would be 1 over 2 plus h minus 1 over 1, which is just 1. Right? Yeah. over h. Oh, I'm sorry. You are correct. That's a 1 there. Sorry. So now this is the limit as h approaches 0. I need, looks like probably common denominators to start, or we could go ahead and multiply through by the, I'll do common denominators and see what happens. So this needs a 1 plus h. Needs a 1 plus h. Just looking at the top here. So I have 1 minus 1 plus h over 1 plus h all over h. I did to the top and the bottom. So it was, this was just 1, that's just 1, right? So I took 1 over 1 and I said I want it to have the same denominator that this one has. So I multiplied by 1 plus h. And if I do it to the bottom, I just did it to the top too. Is anything divided by itself? No, because remember when you add or subtract fractions, so 2/3 plus 5/3 would be 7/3. You leave that bottom the same, right? So I do the same even though it's functions in there, yeah. One over it. Yes. So if it confuses you, think about this is f of x. Or you could say, okay, y of, like that. But yes, that's the equation you're using. Does that not make sense? From the start. So like here, but then you didn't combine. Did you come down to the right thing at the end? That I imagine that got difficult. So simplify as you go, then combine. Does that make sense, Greer? You sure? That's not convincing. We'll do another one. We're going to spend another day on this today, too. Okay. 1 minus 1. So now really what I have, 1 minus 1 is 0, right? But I've still got this negative h up top over 1 plus h, and everybody's over h. Still can't substitute 0 in because there's an h in the denominator. So now what I'm going to do is multiply by the reciprocal of this, because I'm dividing. Oh, I keep putting x here. I'm sorry, y'all. H goes to 0. Negative h over h times, times 1 over h. Y'all good? Say again? I did. So what's the reciprocal of h over 1? I hope you can see the answer now popping out at you. What is it? What's the limit? Yeah, so many times we will have like a page of work and you'll get down to the end and I'll say equals 1 or equals 0 or equals negative 1. And it's so frustrating. The hard part's done for this, right? Now it's equations and things like that, equations of lines, which is easy. All right, what did I find? What is that? It's the slope. The slope of what? Tangent line, and not just any tangent line, but the tangent line at x equals 1. The slope of the tan line when x equals 1 is -1. A point on, or the point of tangency would be 1, what? Two. 2, 1. Yeah, sorry. So now the equation of the tan line. Y minus 1, -1, x minus 2. And if I want to solve it for y. Now I'm done. That's for part B. You can. It's just more room for me to make a mistake. So I just leave it like that. But you can. You definitely can. Slope of the normal line. It's close to the same. But the slope of the normal when x equals 2 is +1 this time. So my equation is going to look very similar. It's just going to be x minus 2. Wasn't that fun, y'all? Yep. Plug in that x equals 2 from the very beginning. What else on your homework? Well, when we get to the next chapter, y'all will be so mad when we talk about slopes of tan lines. Yeah. Tell Lizzie to shut up. Well, but it's you have to learn it because it's tested. They'll literally put like there was a question, I can't remember what year it was, but they released the multiple choice questions after a couple years, and there was one of them, and there generally is something with the difference quotient, but they literally put 4 different versions of the difference quotient that were like ever so slightly different, and you had to pick the one that was the actual definition of the difference quotient. Which one of them approximates the slope of the curve at bleh. All right, at x equals 0. So again, I'm doing the limit as h goes to 0 of f of x plus h minus f of x over h. Lots of just algebraic manipulation here, but here we go. Oh, f of x plus h. Let's see. Oh, I got a 0 in here. Oh, that's not going to be so bad. So really, it's just f of x minus f of 0 plus h is just going to be h squared minus 3h minus 1. Right? And f of 0 is just going to be -1. We all agree there? So I have h squared minus 3h minus 1 minus -1. All right, so if you put a 0 in for your x's here, right? 0 squared minus 3 times 0 minus 1. The second part. Uh-huh. You put, yes, yes. So this is going to be a 0 and this is going to be a 0. And so it's -1. What happens if you have f of x equals x squared minus 3x minus 1? What is f of 0? You put a 0 in for every x. Everybody okay? These two are going to cancel, right? Negative minus a negative is plus a positive. So now I have the limit as h goes to 0 of h squared minus 3h over h. What can I do? Everybody got an h, factor it out, take one from everybody. As long as everybody's got it to give, you can take it. So now I have the limit as h goes to 0 of h minus 3 and plug it in. -3 is what? Slope of the tan line when x equals what? 0. Well, I'm just writing that for your... Give me the point of tangency. 0 point of. So now the equation of the line. Which is just -3x. How about the normal line? Do you feel like it's a lot? Do you feel like it's hard? I got you. Anything else? Well, because this is 0, so it's y plus, the point is still the same. This is still the same. The only thing that changes is that. And since that was 0, it wouldn't change that particular equation. But you're right, you wouldn't want to just do that if that didn't have a 0 there. Anything else? Y'all ready to talk about more difficult tan lines? What, slightly, just slightly. Y'all need a break in between? Okay. So we've talked about tan lines and slopes of tan lines. But what happens if I have a piecewise function? So here's what has to happen in order to have a point of tangency for a piecewise function. Now, this doesn't mean that it has a tan line. It just means that there's a possibility of it having a tan line. And we're going to talk about all those reasons why it may not. But in order for it to have the possibility to have a tan line, then it must be continuous at that point. Remember, that's where my left-hand limit, my right-hand limit are the same, and also is the same as the function at that point, right? It must have a slope, and we'll talk more about what that means. This is actually an or, not an and. Or, I'm not doing the third or just yet. Sorry. But what must always happen is that left-hand limit must equal the right limit. If it doesn't, you're not going to have a point of tangency, or you're not going to have a tan line. Okay, let me show you what I'm talking about. I think this is number 16. Let's go right down. Yeah. Let's say I have calculus loves piecewise. 16 says, determine whether the curve has a tangent at the indicated point. I bet you can guess what point I'm talking about. What do you think it is? Yeah. So does f of x have a point of tangency at x equals 0? And if it does, give its slope. If not, explain why or why not. Okay, so the very first thing I'm going to do is I'm going to check the left-hand limit as compared to the right-hand limit. And I'm going to check to see if it's continuous. So the limit, as I go to 0 from the left, and these are pretty straightforward functions. I got a linear function and a quadratic, right? Both of which are continuous on their own. The limit as I go to 0 from the left of f of x is what? 0. What's the limit as I go to 0 from the right? Now I'll just check continuity real quick. What is f of 0? So my function is continuous, and it is continuous at 0. Do we all agree? So this one I used the second equation because it's greater than 0, and I'm coming in from the right. This one I used the first equation because it's less than 0, I'm coming in from the left. So 3 checks for continuity, left-hand limit, right-hand limit, and function value there. Okay. Think about what this looks like graphically. Not that you have to graph this for this one, but just to show you as we go through this problem. Pre-cal had this exact problem on their test that they had to graph, I feel like. This is a line with a -1 slope. I start at 0, 0. Whoa. Here. Negative slope goes like this. Then this side, I'm still at 0, so I'm 0, 0 inclusive here, right? But my vertex on this parabola, opposite b over 2a, and then I plug that in. 1/4 minus 1/2 is -1/4. So 1/2, this is 1/2, -1/4, and then it's going to come back up. Not that you need to know all that for this one, but just to show you that it is a continuous function. I got a piece of a parabola and a piece of a line. You good? Okay. Well then, now let's see. We've determined it's continuous. It should definitely at 0, it should definitely be able to have a tan line there, right? So here's what we have to do. We have to do the difference. I'm going to hate this. You have to do the difference quotient from the left and from the right and make sure that those slopes are the same coming in from the left and the right. I know. Difference quotient from both sides. If they match, then that's the slope. If they don't, I don't have a tan line there. Yeah. This is a calculator problem. You can use your calculator here. All right, so I'm at x equals 0. So we'll do from the left and the right. So let's do the limit as h goes to 0 from the left. And the big question is, does that equal the limit as h goes to 0 from the right? For these two different equations. My left side equation, remember, was, and I'm going to just write these both here so I don't have to, negative x, and this one was x squared minus x. Is that right? All right, working down the first one. F of 0 plus h is negative h minus 0. 0 plus h is just h, so it's h squared minus h minus 0. Yeah, tell me when you're caught up. Okay. On the left, this is just negative h over h. And on the right, you with me? So this is really the limit as h goes to 0 from the right, or from the left, I'm sorry, of negative 1. So it's of a constant, which is just negative 1. This one that's what I was looking for. I was looking and hoping that whenever I did it from both sides, it was the same. Since it's the same, so we check for continuity, we check both sides of the difference quotient, and since it's the same, then I can therefore say, therefore, the slope of the tan line when x equals 0 of f of x is negative 1. I was not asked to write an equation, I was simply asked to find the slope. Y'all okay with that? For sure? Same thing, I'm just doing it from both sides this time. If that wasn't the same, then nope. It does not have a tangent line at that point. Y'all okay? Yep. That's all you would write. Let's look at some types of functions and what their tan lines, when you may not have a tan line to exist. Let's say I end up with a piecewise that's continuous, something like this. What's going to happen on this is, even though it's continuous, my slopes as I come in aren't matching, right? So I'm not going to have a point of tangency there. I'm not going to have a tan line at that point because the slopes aren't matching there. Does that make sense? Look what I'm doing. Yeah, that makes sense. Do you think you have a tan line here at this point? No, it's not even continuous. If it's not continuous, that's not even in questions, right? Even if the slopes matched coming in, if I did the difference quotient here and I did the difference quotient here, they'd be the same, but it's not continuous. Well, that's not the same, but if I did it where, okay, that's not, because let me show you what I'm talking about. We'll just make it linear. If you did the difference quotient here, right, the slope here is the same as the slope here, but the continuity is keeping me from having a tan line. Does that make sense, what we're saying? Okay, so that's why you have to check everything. That's all I'll say about that. It's got to be continuous, and the slopes coming in from the left and the right have to be the same. Well, we put have a slope because it must have a slope at that point. Something, and we'll get into what this means later, but if we have a function that comes in at a point like that, it doesn't have a slope there, and so it doesn't have, it's not a defined tangent line there. We'll talk a lot more about those two things. Don't worry so much about that right now. We'll talk a lot more about that when we get to the next chapter. I should just skip that. I should just said, okay, just get that part. Check the limits, both sides. So check for continuity. Continuity and both sides for the difference quotient. Sure, it could. So with something like this, I do have a tan line here. I just don't have one here. Is that what you're asking? Yeah. Right. So we're looking at continuous at that point, at that particular point. That was a good question, though. So, yeah. Continuous at the point. Other questions about that? One more and I'll stop. Differential, I mean difference questions, not differential. This is number 28. After t seconds, at t seconds after liftoff, the height of a rocket, so the height is 3t squared. Feet. So you got your units. How fast is the rocket climbing after 10 seconds? So we're talking about speed now. Okay, so speed, with what we want, okay, so we have the feet. We could plug in 10 here, but all that's going to tell me is how high I am at 10 seconds, right? At 10 seconds, I'm 300 feet in the air. That's not telling me speed. The speed is going to be in feet per second, right? Do we agree? Okay. So what I want to do, because I'm looking at a specific time, I'm not talking about the average speed over 10 seconds. I want to know what is the speed at 10 seconds. What does it sound like to you? It does. Sounds like a difference quotient problem. It absolutely does. So let's do it. The limit as h goes to 0. Remember, it's f of t plus h, but since I've got an h here, that's kind of confusing, so let's make it f. Your book uses h because it's height. I'm putting a 10 in for x because I want exactly at that moment. Y'all try this one, see if you get it, and then I'll do it with you. The t is x, yeah. Sorry, this x is just, that f and x just ingrained in my brain. If that is what you got, or it's not what you got. Oh, that's why you're doing. Look at you. Oh, 3t squared. Okay, so where do you see 20h? Foil it out. It's 10h plus 10h, which is 20h. If you foil out 10 plus h, 10 plus h, you get 100 plus 10h plus 10h. H squared. Oh. It's always the algebra. It's always the algebra. Notice the units, always keep the units in your answer, very important. I need to give you a couple of equations, and I'm going to stop and let y'all work a little bit. Number 30 you'll have on your homework. It asks you about the volume of a sphere. It says, what's the rate of change of the volume of a sphere with respect to the radius when the radius is 2 inches? So I'm looking for I rock at 2, but I need to know the volume of a sphere. Does anybody know the equation for the volume of a sphere? So you're doing, so your f of x, if you want to use x, would be 4/3 pi x cubed, right? And then the equation says when r is 3. So you're doing difference quotient there for that. If I ask you where a point, at what point is the tangent horizontal? What does that mean about a slope? What kind of slope does a horizontal line have? 0. So what you're wanting to do is find where it equals 0. So you set that difference quotient equal to 0. Yeah. Yeah. I think you should be okay other than that. Yeah. We're getting close to, this is the last section in this chapter. We'll probably review a little more for this test than what we will most tests because you're just getting started. But I want to make sure I fill in all your holes from pre-cal and algebra 2 also. So if there's things you don't remember and need me to go over as we get to stuff, let me know. Things like, I don't know, whatever, factoring, completing the square, things that you don't remember how to do, rational functions, complex fractions, any of that. Not yet, but what I'm saying is if you get to something and we need to review it, let me know. All right. What are we doing for homework? We are going to do we did one of those. It looks like more than it is because I'm giving them to you just one problem at a time because I don't want to overload you. Do 24, you should be able to do it. Let's make that 25 instead of 24. I think that's enough. Let's stop there. I don't want you to think. We'll do some more practice on Monday. Yeah.